respected dignitaries, participants from the various institutions, and my dear colleagues. A very warm good morning to one and all. I, S. Reshma, Assistant Professor, Department of EEE, delighted to welcome you all on behalf of Gates Institute of Technology for the 5 days faculty development program on emerging trends and challenges in renewable energy systems organized by Department of EEE, Gates Institute of Technology, Gutti. Learning gives creativity, creativity leads to thinking, thinking leads to knowledge, knowledge makes you great. It's my pleasure to invite the convener to this faculty development program and the head of the department, Dr. Narsimulu sir, to address the gathering.
Respected keynote speakers from premier institutions, delegates, colleagues, ladies and gentlemen, and participants of various institutions, good morning, one and all. On behalf of Electrical and Electronic Engineering Department, Gates Institute of Technology, I am delighted to welcome you this morning, a 5-day faculty development program on emerging trends and challenges in renewable energy system. Thank you for being here on this virtual platform and to bring your energy, ideas, and expertise. And we have 200 plus participants from the different parts of the country. The main objective of this FDP helps to faculty members to stay updated on recent developments in renewable energy systems and foster the cutting edge research to contribute meaningfully in the evolving field of renewable energy systems. I would like to welcome and give special thanks to our Managing Director, Sri G. Raghunath Reddy Garu, our correspondent Madam, Srimati V.K. Padmavathamma Garu, and our Director Madam, Srimati V.K. Srivani Garu, and our beloved Principal Madam, Dr. Syed Surya Garu, for their suggestions and support. And my team who have been supported me throughout this program right from its instruction, and I welcome and thanks today's chief guest, Professor P. Sujata Madam Garu, Director of Foreign Affairs and Alumni Matters, JNTA Anantapur, for giving valuable time for us in spite of her busy schedule, and also I welcome all the eminent speakers. Gates Institute of Technology was established.
Thank you, ma.
Thank you, madam. Thank you, madam. Established in 2001, it is affiliated to JNTA and accredited by NAC and NBA. The institutions also got autonomous status and recognition of 2F and 12B from UGC. And also, institution is certified by ISO. The focus is inculcate continuous learning habit with positive attitude and ethically sound values within the faculty and students. The institute has always invested in instilling life skills among the students throughout their participation in various curricular, extracurricular, and co-curricular activities. Progressive thinking of our late correspondent Sri V.K. Sudhir Reddy Garu has made Gates stand tall on one of the very first and few educational institutions to the completely run on solar power. Institution is headed by Dynamic Managing Director Sri G. Raghunath Reddy Garu, correspondent Srimati V.K. Padmavathamma Garu, who is the heart and soul of our institution, and Director of Srimati V.K. Srivani Garu, who is giving the new direction to the institution. The Department of Electrical Electronic Engineering has intake of 60 for UG. The department was well qualified, dedicated, and experienced faculty and committed support staff. The institution also allows the students to further enhance, update, fine and tune much needed specific domain skills and soft skills through the various training programs and workshops and different levels. In order to facilitate this, the institute signed an MOU with Village Energy Australia, APSSDC, IUCEE, Florida Atlantic University, USA. Thank you for giving this opportunity. Thank you, madam.
Thank you very much, sir, for giving your valuable insight on FDP. Now, I would like to request the Sabia Sultana to give a brief introduction about the today's our chief guest of this program, Dr. Sujata Madam.
Thank you, Madam, for giving the opportunity to introduce the today chief guest of this FTP program, Professor P. Sujata Madam. Madam is currently serving as a professor in the Department of EEE in JNTUA College of Engineering, Anantapuramu, and Director of Foreign Affairs and Alumni Matters, JNTUA, Anantapuramu. With over 20 years of teaching experience, Madam has held many positions in JNTUA HOD and Principal of JNTUA College of Engineering. She has a membership in reputed several professional bodies. She has 10 years of research experience, published more than one international and national journals, and published one book and two patents. To her credit, she has supervised 12 PhD students and supervising 5 students. Recognized for her exceptional contributions, she has received prestigious awards. Now, I request today's chief guest of FTP, Professor P. Sujata Madam, to address this program.
Thank you, Ma. Good morning to all the dignitaries and the entire gathering. Padmavatama Garu, correspondent of the college, Raghunatha Reddy Garu, managing director, Srivani Garu, director, experts from various prestigious institutions, Senthil sir from NIT Trichy, who has very good association with us, Principal Syed Suraya Garu, head of the department, Narsimhulu, coordinators of FTP program, Ramakrishna and Paramesh Garu, organizing committee members and faculty members, participants, and students. A warm welcome to you all for a 5-day online FTP on emerging trends and challenges in renewable energy systems. At the outset, I would like to thank administration of Gates Institute of Technology for giving me the opportunity to act as chief guest of today's inaugural session. Coming to today's program, conducting faculty development program like a regular activity nowadays because of online supportive systems which are available to us. Topic of FDP is very good and which is useful for many faculty members to motivate them towards research in the area of renewable energy systems. So many drastic developments are there in the field of renewable energy systems day to day, due to which so many researchers are working in this area. The world's future depends significantly on how we power our present needs. As the adverse effects of climate change are becoming more pronounced with every passing year, the choice between renewable and non-renewable sources of electricity is clear and has becoming urgent. So, more so because of the window of meeting global climate goals is closing fast. India has committed to reach net zero carbon emissions by 2070. Thankfully, compared to the rest of the world, India is already on the next level when it comes mitigating climate change through renewable inventions. While the country plans to add 50 gigawatts of renewable energy capacity annually to reach the target of 500 gigawatts by 2030, bringing solar and wind into the country's energy mix has been one of the most innovative moves. Solar and wind energy currently contribute more than 50% of the total renewable capacity of the country. According to official data, India had a fully renewable energy capacity of 168.9 gigawatts, including 67.82 gigawatts of solar power and 43.20 of wind power as of 30th May 2023. Not only is the country quickly scaling up its renewables capacity, but the results of the efforts are also visible in multiple emerging trends defining India's solar and wind industries. Following are six of the most noticeable trends in India's renewable energy space. One is due to increasing awareness among residential consumers and government subsidies, there has been a spurt on solar rooftop installations nationwide. Second one is the growth of domestic solar photovoltaic module manufacturing capacity in India. Third one is India produced about 64.5 billion units of electricity from wind energy projects during 1 year span. The fourth one is the government is implementing the scheme for developing ultra mega solar power parks. This will boost the investment and construction of new projects. The renewable energy industry is also quickly tapping the potential of newest technologies like blockchain, AI, and machine learning. The last one is the renewable energy industry in India is heavily investing in research and innovations in solar module and battery storage technologies. It is my hope that the above trends are in the right direction. India is poised to demonstrate to the world its commitment towards reaching net zero carbon emission and providing cost effective clean sources for our energy needs. Anyway, all the experts who are enlisted for this FTP are highly involved in the renewable energy research and they will give full insights of the corresponding topics. I hope this 5-day FTP will give fruitful information to all the participants and provide an opportunity to grow themselves and those around them. Once again, I thank the college administration, faculty coordinators, and their organizing teams for giving me this opportunity. Thank you, one and all. Thank you.
Thank you, madam, for enlightening us with your inspirational words. We will try to make use of the program to improve our skills, and I thank you very much for your inspiring words. And we are thankful that you have accepted our request and graced the occasion in spite of your busy schedule. Thank you, madam. Thank you very much.
Thank you, Ma.
Now I would like to request our beloved principal madam, Dr. Sayasura madam, to address the gathering.
Yeah, thank you, Reshma, for giving me this opportunity. Good morning, everyone. On behalf of Gates Institute of Technology, Gutti, I, Dr. Syed Suraya, Principal, delighted to welcome on board all the dignitaries, eminent personalities from various institutions for this 5-day online faculty development program on emerging tech trends and challenges in renewable energy systems. First of all, I would like to congratulate the Department of Electrical and Electronics Engineering for taking initiative to conduct this FTP, and I thank our today's chief guest, Professor Sujata Madam, and today's session speaker, Dr. Senthil Kumar Sir, for accepting our request. Thank you, sir, and thank you, ma'am. And I would like to I would like to thank all the session speakers for accepting to give insights on trends and challenges in renewable energy systems. As educators and researchers, it is imperative that we remain at the forefront of understanding the evolving landscape of renewable energy. The world is witnessing a transformative shift towards sustainable energy sources, and it is our duty to equip ourselves with the knowledge and tools to prepare our students for this changing paradigm. Today's discussions will help us recognize the latest trends, breakthroughs, and the challenges that accompany the integration of renewable energy systems. I encourage you to actively engage in all the sessions, share your insights, and collaborate with colleagues to explore innovative teaching methodologies and research opportunities in this domain. Let's aim to inspire our students to become catalysts for sustainable change, fostering a new generation of problem solvers committed to addressing the global energy challenge. Thank you for your commitment to continuous learning and for your dedication for shaping a better, brighter, sustainable future. I am confident that today's program will enrich our understanding and empower us to make a meaningful impact in our classrooms and beyond. Thank you. Thank you for giving me this opportunity.
Thank you, madam, for your inspiring and motivational words. Now I would like to request the co-convener, M. Parameswar, give the brief introduction about the today's our speaker, Dr. Senthil Kumar sir.
Thank you, madam. It's my pleasure to invite today's speaker, Dr. S. Senthil Kumar sir. Sir completed PhD from NIT Trichy. Sir has been working in NIT Trichy from 2006 onwards. Sir has supervised 10 PhDs. To his credit, Sir has published more than 70 papers in international and national journals. Sir has completed 10 sponsored projects. So now I request Day 1 speaker, Dr. S. Senthil Kumar Sir, to take over the session on topic design and development of solar photovoltaic powered cold storage system. Thank you.
Thank you, sir. Thank you for your introduction. Can I share my screen?
Okay, sir. You can share.
So it is. I'm not able to share entire screen. Yes. My screen is visible, sir.
Yes, sir.
Okay,
Visible,
fine.
sir.
Very good morning to all of you. Shall I continue the my?
Yes, sir, you can, sir.
Yes, sir.
Yes.
మా సూర్య సార్ కంటిన్యూ చేయొచ్చు కదా?
Yes, madam.
Yeah.
Very good morning to all of you. First of all, I thank the management, principal, head of the department, faculties, students for conducting such programs. It is very much essential for the society. Today's my talk is related to the solar PV system, solar PV powered cold storage system. In fact, we had this titled project from DST. Whatever our experience, I just want to share here in addition to the technical content. Here we actually, the title is cold storage system. When you are referring cold storage in India, the India is the largest producer of fruits and the second largest producer of vegetables in the world. It is very clear. So in spite of that, per capita availability of fruits and vegetables is quite low because of forced harvest losses, which account for about 25% to 30% production. Besides the quality of sizable quantity of produce also deteriorates by the time it reaches the consumer. Most of the problems relating to the marketing of fruits and vegetables can be traced to their perishability. The perishability is responsible for high marketing cost, market glouts, price fluctuations, and other similar problems. At a low temperature, perishability is considerably reduced and the shelf life is increased, and thus the importance of cold storage or refrigeration. So in this regard, we have chosen the powering for cold storage system is based on the solar photovoltaic system. So here we will discuss some significant achievement. These are the contents like a background, objectives, methodology, R&D collaborative project, a target deliverable, system description, results and discussion. So work to be done in future and activities. So I told you that the major issue faced by the Indian farmer community is the lack of mobile cold storage facility to reduce the forced harvest losses, specifically from the farmers filed to the cold storage facility. Already I told you one more information. India is the second largest producer of horticulture commodities. Like fruits is 88.9 metric ton and vegetable is 162.887 metric ton. This is the database which we have collected. Per capita availability of the fruits and vegetables is quite low. Cultivation is less due to a risk of crop failure, price volatility, spoilage, and poor storage. The post-harvest losses, I told you that around 34 to 40% of the total production of the fruits and vegetables, that is rupees 133 billion per year by Ministry of Food Processing Industries, Government of India. So the identification is a lack of adequate cold storage facilities and refrigerated transport. So in this regard, the limitations with respect to the existing cold storage system we were identified. The lack of logistics connectivity to ensure that their harvest reaches markets in time results in lowering of the farmers' ability to monetize their produce to single temperature and RH is maintained. And multiple fruits and vegetables are stored even though they required a different temperature and RH, resulting in spoilage of fruits and vegetables. So this is what the original image which we have taken from the area, one of the area, highly cultivated fruits and vegetables area in Tamil Nadu. The place is called as a Vattanjatram. That place only we were taken this photograph. So resulting in spoilage of fruits and vegetables. The demand is the wastage of fruits and vegetables due to lack of adequate cold storage facilities at their fields and retails, refrigerator transport for long distance. This is also the original image. The vegetables thrown as a waste for every day due to non-availability of the cold storage. So if you are referring the food processing industry, simply you type in the Google cold storage system, you will get lot of information, how the ministry is focusing, how the agriculture university is focusing for cold storage facilities. Those information you will get it. Actually, it is an interdisciplinary area where we are going to use the renewable energy. I will come to you that point later. So requirement of the renewable energy for the above facilities is also needed. So then the challenges in the cold storage system is unreliable power supply and the cost of running on generator set, ongoing maintenance, price, capital investment, distribution of cold storage facilities, lack of vertical integration, low awareness among us industry players about best practices in storage, lack of trained manpower, many things are there. So these are the important challenges in the cold storage. So the scope of our work we considered with respect to our DST project is strengthening the agricultural sector by reducing the forced harvest losses to achieve food security. So, and another one is ensured energy security through sustainable energy production. And we were started to use the phase changing material based cold storage system. So then the mobile portable cold storage system and the mobile storage cold storage system with the help of solar power and PCM, which may overcome the post harvest losses and avoids the power supply interruption of the cold chain. So these are the scope which we committed. The stages in the cold state. So first one is harvesting. Second one is this is harvesting, then pre-cooling, then transportation, then sorting treatment, then cold storage. That is here we are started to use with the renewable energy, then long transportation, then retail. So even though the cold storage facilities are available, the first cold storage in India was reported to have been established in Calcutta in 1982. However, significant process in expansion of the cold storage in a industry in the country has been made only for independence. So, with a view of ensuring the observance of proper conditions in the cold stress and to providing for development of the country in scientific manner, the government of India and the Ministry of Agriculture uh, promoted an order known as a cold storage order, 1964, under the section of 3 of the Essential Commodities Act 1955. The agriculture marketing advisor to the government of India is the license officer. So these are the some information. A cold storage facility accessible to them will go a long way in removing the risk of distress sale to ensure better returns. So these are the some information. Our focus is here only. As an electrical engineer, we committed this portion only. So how we are going to develop the cold storage and the powering through solar PV. So these are our commitment. These are the details of our collaborative project. Actually, this project we were executed with at NIT Trichy and the Indian Institute of Food Processing Technology. This is also a centrally funded institution. So located at Tanjavur, they are running with BTech in food processing and food engineering, MTech in food engineering and a PhD in food engineering. The total cost of the project is this much. So this is for your information. And the objectives which we were committed with to increase the shelf life of various fruits and vegetables by controlling the temperature and the humidity under different operating conditions, to reduce the wastage of fruits and vegetables, to save the grid energy by proper utilization of solar energy. So systemization of hybrid cold storage system room by incorporating the solar energy and phase changing materials. So these are our developed units at NIT Tiruchirappalli. So this is the first cold storage room and the second cold storage room, compressor. So these are during inauguration only we were taken. For research purpose, we made it with 3 rooms. So 2 cold storage room and 1 conventional storage room we were made. So in the for test purpose. So later we will come here how we were developed the cold storage system through PV. So before that, I just want to give some more introduction related to the food industries. So storage of foods and storage conditions. So foods and many other commodities to preserved by storage at low temperature, which retards the activities of microorganisms. So microorganisms are the spoilage agents and consist of bacteria, yeast, and molds. Low temperature does not destroy those spoilage agents as does high temperature, but greatly reduce their activities, providing practical way of preserving perishable foods in their natural state, which otherwise is not possible through heating. So the low temperature necessary for preservation depends on the storage time required. Storage time required often referred to as short or long-term storages and the type of product. So in general, there are 3 groups of products of foods that are alive at the time of storage, distribution, sale. Example, fruits and vegetables. So foods that are no longer alive and have been processed in some form. For example, meat, fish products, and commodities that benefits from storage at controlled temperature. So example is liquor, like beer, tobacco, many things. So living foods such as fruits and vegetables have some natural protection against activities of microorganism. The best method for preserving these items is to keep the product alive and at the same time retard the natural enzyme activity, which will retard the rate of ripening or maturity. So the so these similarly, like the preservation of non-living foods is more difficult since they are uh, susceptible to spoilage. The problem is to preserve dead tissues from decay and putrefaction. Long-term storage of meats and fish, a product can only be achieved by freezing and then storing in that temperature below minus 15 degrees centigrade. And so these are many informations that we can see with respect to the storing of foods, I mean fruits, vegetables, meats, like this. So the products such as apples, tomato, orange, etc. cannot be frozen, and close control of temperature is necessary for long-term storage. Some product can also be benefited by storing under controlled temperature and modified atmospheric conditions. Dairy products are produced from animal fats and therefore non-living foodstuffs. So they suffer from oxidation and breakdown of their fats, causing rancidity, packaging to exclude air, and hence oxygen can extend the storage life of such foodstuffs. So in this regard, you can refer with respect to the engineering aspects, many technologies which is available, like a vapor absorption technology and vapor compression technology. So like that it is there. So based on the cost, we needed to choose those technologies. So when you are referring, many standards is also available. So like the storage environment of the fruits and vegetables, how much the shelf life is can be improved, many things it is there. Government is promoting many things with respect to the foods. So like very recently you would have seen that like International Year of Millet. So, in fact, our Prime Minister, Sri Narendra Modi ji, is also said that there is much food diversity in India, as there is cultural diversity. So, the world celebrated 2023 as the International Year of Millet. Millet is a part of India's superfood bucket. So, uh, and as been identified by the government as a green grain. So these are some informations related to this, and we will see the standards. What are the food industry's requirement? Like everything, we need to maintain some temperature and some shelf life. It will be increases, like carrots, cherries, cucumber, brinjal, grapes, lemons. So many things it is available that we will discuss here. And so our uniqueness, novelty with respect to our project is multi-commodity solar PV based cold storage system for fruits and vegetables. If you are referring the conventional refrigerator, for example, the fridge which you are using in your home, you are dumping the entire fruits, I mean the fruits and vegetables in the same temperature and the same RH. Even you can see that certain fruits and vegetables, the skin, it is changing uh, uh, with the same RH and the same temperature if you are maintaining. So in this regard, we consider with multi-commodity. So multi-compartment. Each compartment is having own temperature and own RH. This is only we considered here. And a low melting temperature phase changing material is also used to store and circulate in the cold storage rooms instead of a direct evaporation of the refrigerant. So excess cold storage is stored in the phase changing materials and is utilized when the absence of solar PV and grid power. Energy saving and cost effective when compared to the battery storage system, that also we were proved with respect to this project. And the methodology which we were followed, these are the some methodologies. So this methodologies only we were executed during our project. And the targeted deliverables is engineered PCM based 2TR prototype model of the solar PV based cold storage systems for fruits and vegetables. Here you can see that some images which we have taken from the uh, uh, internet only. You can see that some images are there, how the cold storage rooms are transporting to the harvesting area itself, and are retailers. And the prototype unit for multi-commodity cold storage system to reduce the post-harvest losses, demonstration through workshops, seminars, and trainings for farmers, academicians, and stakeholders, awareness creation among farmers regarding the temperature importance of PV-based cold storage system through the field demonstrations. So creating skilled manpower for food industries and academic industries. So these are our targets. So coming to the system description. So here only I am coming to the technical points. So in the system description, you see that the PV is there. So this is here PV is there. So this PV is connected to the DC to AC power converter. It's the same PV, only the grid is also connected, and it is fed to the compressors. So through the compressor only we are controlling the temperature. This is the chamber 1, commodity 1, commodity 2, commodity 3, like that. So here the phase changing material also we kept it. This is the many phase changing materials we were used. One of the material which we were used is HS101 in Adia. That's why we were called as a hybrid cold storage system. Hybrid in the sense we are powering from solar PV, grid, and PCM. When solar PV is not there, we can use it grid and PCM. When PV and grid is not there, we can maintain the required value of the temperature and relative humidity through the PCM itself. That also it is possible. So that's why this is what the system description. And this is the representation of the cold storage room. Whatever I shown the photographs, the same thing only. So this is the cold storage room 1 and cold storage room 2. And here we are having the temperature controller, humidity controller, and evaporator with UT plates. That also it is available. So similarly here, the second one is not a cold storage room. It is a conventional storage room with a compressor unit and humidity controller for second one. This is the size specifications, everything here it is given. And in fact, we required the power converter. The power converter, it is a DC to AC power converter for processing this. I will show you the system description, how it will be. 1 minute. Can you see the diagram? Yes. At least can you respond one?
Yes, sir.
Yes, thank you. So conventionally, when you are referring the grid connected system, how it will be? It looks to be like this. The PV array, one DC-DC converter, it will be there. This is what the DC bus and the inverter. So the inverter, it is connected to the grid. And sometime we used to connect the battery storage in the DC bus. So here we in the DC bus, we can connect the battery storage also. When the PV is not available, the battery, it will supply the power to the grid, or when the like this. So this schematic only, it is more applicable for our system. So the PV is there, DC-DC converter is there, but a DC-DC converter we were not used since research purpose we can use it, that may not be the issue. We were not used since we were increased the size of the transformer at the grid terminal. So the commercially available grid connected inverter only we were started to use for our cold storage system. And the main thing is in the DC bus, this is the DC bus. Normally they used to connect with the battery, but here we are not using the battery. Sometimes it is used for the battery also. So here you can see that the PV power, it is processed through the DC-DC converter. So here we are having the DC power. That DC power, it will be converted to the AC, then it is fed to the grid. Or we can connect it here in this terminal, we can connect it with the local load. This is for our purpose. So here only we connected with the compressor 1 and the compressor 2. The earlier diagram which I have shown here, no? So that diagram, yeah, in this diagram you can see that very clear. The output of the DC-DC converter directly it is connected to the load. So here only that load 1, load 2, I mean the compressor 1, compressor 2, like this, it is connected. So the important information is here it is, when you want to operate with this inverter without having the boost converter, the synchronization is very much essential. The grid synchronization. The grid, it may be the single phase grid or 3-phase grid. So normally we used to have the PLL. So PLL were used for synchronizing the grid and the inverter. In this regard, then the inverter control is also required when you want to transfer from power to DC bus to here. And sometimes we may use with the DC-DC converter also for MPPT purpose. This is very clear. And the synchronization techniques were used is either it may be the open loop technique or closed loop technique. The open loop technique is measuring the VA, VB, VC and converting to the alpha beta. Then finally we were estimated with the sin theta and cos theta signals. So these signals are very much essential for control applications. And closed loop VLL is widely used for synchronization algorithm. And the classification is the zero crossing detector is the conventional one. So it is very simple and the phase detection is possible only for at zero crossing points. And the reference frame PLL is widely used. It provides a satisfactory performance under balanced condition, poor performance under unbalanced condition. So this is the structure of the PLL. So in the PLL, first stage is the phase detector, second stage is the loop filter, the third stage is the voltage controlled oscillator. So the here always the theta signal is very much essential, and the effect of utility. So effect of utility distortion on the PLL performance is the unbalance, harmonics, DC offset, phase jump. So these are the mathematical equations corresponding to the unbalance. So the unbalance is created through the factor of x. So the corresponding D and Q that it is represented here. And the harmonics. The harmonics, when the harmonics is applicable, that time how it will be the PLL is reacting. This is VD and VQ. This is a corresponding mathematical equation. Similarly, the DC offset. With respect to that, these things, this is the mathematical equations which we developed from the circuit theory concepts, and the corresponding VD and VQ, how it will be. Similarly, the phase jumps. The how it will be. So the effect of distortion on the DQ frame is unbalanced. Twice the frequency, ripple frequency is there. Harmonic 6 times the frequency is there. DC offset the same frequency it will be there. And phase jump 2 times. So to address this, we can use with the PLL which is available in the the conventional PLL like SRF PLL. So this is the balanced voltage, alpha beta to DQ is this one. So finally theta we are getting. When unbalance comes, the faster transient response under balanced and distorted conditions we may get it. But a distorted output under non-ideal conditions, it is not possible. The steady state error under frequency deviations, it will be there. And one low pass filter were introduced, and with respect to that, improved filtering characteristics under distorted conditions we may achieve. But this provides the low transient response, a steady state error under different frequency deviations. So in general, when you are referring the filtering characteristics with respect to the magnitude versus the frequency, and this one is the bandwidth, when the bandwidth of the low pass filter. So when the bandwidth is reduces, then you can see that a filtering characteristics. So how it will be moving. When the bandwidth is increasing, the filtering characteristics it is reduces. So in this regard, some notch is also introduced, and this will provide the improved transient response, but a steady state error under the frequency deviations is also less. So many the many stages also people were applied. So finally they are not able to get with the response under frequency deviations. So distorted under harmonic conditions. So in this regard, some people were adaptively linear optimal filter is also used. Computationally load depends on the number of harmonics were considered. So extended PLL also they were developed, but difficult to implement practically. The observation is a feedback control loop tracks the phase angle and frequency. Forward frequency is kept constant. Increased complexity in phase detector section. Poor performance for large frequency deviations unless a compromise is made for filtering characteristics. The requirements is the fast transient response and a good filtering characteristics under distorted conditions, zero steady state error, and improved dynamic response under large frequency deviations. In this regard, we were introduced this one with the filter, FIR filter, and one feed forward technology is also introduced for us. So then improved filtering characteristics under distorted conditions we were achieved, improved transient response, a faster response under frequency deviations also we were achieved. So these are the experimental results which we were tested for research purpose. Later I will come to you for cold storage system. Since it is a grid connected system, no? This is what the V alpha, this is the cos theta, and this is the represents with the theta. So this is the input signal corresponding V alpha and cos theta signals and theta signals we were obtained from experimentally it is shown. So under unbalanced condition, you can see that this is the SRF PLL response. You can see that the unbalance is created here with respect to one phase. So one phase, the magnitude, you can see that here it is less. So this is the experimentation. The corresponding cos theta signal, you can see that in simulation and experimentation. And this is only, it is going to be decided it is going to be decided for the control, and this is the PLL under harmonics. So under harmonics, you can see that the I5 and I7 we were introduced, and the total harmonic distortion is 30%. With respect to the cos theta signal, how it will be, and the response of PLL under DC offset also we were considered, and the PLL response, PLL how it is changing, and the phase jump how it will be, the corresponding value of the theta. So the response of the SRF PLL with the FPLL with a step change in the frequency from 40 Hz to 50 Hz, that also we were verified through simulations, SRF PLL and FPLL, and a corresponding cos theta signal also we were verified with respect to how much time it is going to take for responding the cos theta, and response of the FPLL with a step change in the frequency, that also we were measured. So finally, we were observed that with the forward loop, our systems were improved more with respect to the balanced condition, unbalanced condition also, harmonic condition also, the frequency deviated conditions also. So these are the some results, and now I will come to the cold storage system. These are the some results which we were executed, and these are those some results. Coming to the cold storage system. So far we have seen with respect to the grid connector system. So in the cold storage system, we were having a PV panels. This is the PV panel. This PV panel is connected to the DC to AC power converter along with the controller. All are closed loop controller only. We were having the metering point is here also one metering point, and this is the utility grid, 415 volt 50 Hz grid and circuit breaker. This is the metering point, RYB. This is the three-phase AC mains, and we were using with two compressors, compressor 1 and compressor 2, and circuit breaker 3 and 2 and 3 is there. Then metering points also we were created for analysis. I told you that many help we got it for developing the system from Food Processing Institute located at Tanjavur. It is also the institute for national importance. The students were admitted under JEE examination. This is for your information. And these are the developed units. So like control unit, this is the control unit, and a compressor. So here one compressor is there, and a cold storage room 1, room 2, and a digital controller which we are having, and some monitoring units. And this is the representation. You can see that where the fruits and vegetables were stored, and banana, like a potato, mango, apple, many things we were tested. And these are the information about that project, the cold storage system project. And these are the specifications with respect to our design. So the solar PV panel specification and the PCM specification. I told you that PCM is the phase change material. So the phase change material, the material which we were attached in the wall of the cold room, and the thickness, system insulation thickness, mass of the PCM, relative humidity, many parameters we were considered, and the PCM details are, the phase change materials are organic or inorganic chemical compounds that have large amount of heat energy storage in the form of latent heat, which is absorbed or released when the material change state from solid to liquid or liquid to solid. So the PCM retains the latent heat without any change in physical or chemical properties over thousands of cycles. So the application says PCM provides energy efficient solutions for many industries, including insulation for building and piping products, biopharmaceutical transportation, telecommunications and heat sinks, hot and cold storage, food, poultry, milk products transportation, boiler and hot water systems industry looking to exploit off-peak electricity tariff, reducing chilling requirements, so cost by storing energy at off-peak hours. However, there is no limit as to who can apply phase changing material technology to their operation to improve thermal management, cost and energy efficiencies. So these are the some information related to the phase changing material and the technical details, specifications. So the product is a save product and series is HS01. And you can see that the mixture of inorganic additives and appearance is light blue to dark and blue colored liquid. So the corresponding enthalpy, how it will be. And these are the same details, but a different manner which we have given. Coming to the food quality analysis. So up to this, I have discussed how it will be the system, the cold storage system, how we are using the PV, grid and phase changing material. All these things we were using for maintaining the required value of the temperature and relative humidity. Coming to the food quality analysis, we were considered with the mango and banana, and vegetables we were taken that tomato and potato. So the various parameters tested are, one is a physical, loss in weight, moisture content, color, chemical properties like TSS, so total soluble solids, pH, acidity, bioactive components, textural is the firmness. So biological and microbial product, parameters like insects, total plate count, and yeast, fungi, everything we were considered. And coming to the food quality analysis, the shelf life for study of freshly harvested potatoes stored at different temperatures. So ambient temperature 20 degrees centigrade, 8 degrees centigrade and 4 degrees centigrade for 17 weeks. So if we are maintaining this one 20 degrees centigrade, 8 degrees centigrade and 4 degrees centigrade, even we can maintain with the 17 weeks. The quality analysis of freshly harvested ripened tomatoes stored at different temperatures we were considered. So the physiochemical analysis of freshly harvested ripened mango also we consider, and temperature. For the optimized temperature, heat transfer study was initiated for storage of tomatoes. These are some information. This study we performed at Indian Institute of Food Crop Technology, Tanjavur. So here the food quality analysis, the parameters evaluated here, it is a physiochemical properties, textural properties and microbial load. So potatoes at 1 week interval. So here the temperature and the relative humidity which we were kept it, and these are the information. The result is a water content, pH, soluble solids, total soluble solids, reducing sugars, protein, texture and color are maintained even after 17 weeks of storage at 4 degrees centigrade. This is for your information. So then the percentage of moisture with respect to weeks, you can see that the moisture of potatoes stored for 17 weeks, the first one is, the ambient temperature, the percentage of the moisture, you can see that. The second one is the 20 degrees centigrade, 8 degrees centigrade, and 4 degrees centigrade. You can see that the weight loss, we observed that 21 percentage at ambient temperature, that means around 35 degrees centigrade, whereas 6 to 8 percentage weight loss at 4 degrees centigrade. Every day we used to take weight of the potatoes also. And protein content are reduced to 48.72 percentage at 35 degrees centigrade, whereas only 6.41 percentage reduced at 4 degrees centigrade. So total soluble solids are that also we were verified with respect to different temperature and for the 17 weeks. And similarly, the food quality analysis we were considered with respect to the tomatoes. I just want to tell you with respect to the tomato, my experience very recently, I could see that the tomato color is very good color, very red color. And when we are cutting, we can see that white insects. So because how they are forming inside the tomatoes, in the sense irregularity in temperature and the relative humidity only. So here we consider that physiochemical properties, textural properties, microbial load of potatoes. So at 5 days, tomatoes at a 5 days interval, shelf life of ripened tomatoes can be extended to more than 15 days when stored at 20 degrees centigrade and 80% of the RH. The major observation is the tomatoes at ambient temperature gets shrinked and spoilage within 4 days. At low temperatures, tomatoes affected by by chilling injury due to leakage of ions, malondial and proline content. Spoilage after 6 days, 8 degrees centigrade. Spoilage after 10 days at 15 degrees centigrade. Order of increase in pH, that also we were considered. Our observation is a 90 to 95% of water content is at 20 degrees centigrade. Wide difference in color at 15 degrees centigrade and 8 degrees centigrade due to black color of blemishes. So lycopene content of 106 to 113 milligram per kg maintained in 20 degrees centigrade for 15 days. Ascorbic acid content, so conserved under 20 degrees centigrade. Everything we were measured and reported in some journals. And food quality analysis we were considered for the mango also. You can see that ambient condition at 1 week. This photograph, 20 degrees centigrade after 2 weeks, this photograph, and 12 degrees centigrade after 3 weeks. This is 8 degrees centigrade after 2 weeks. So there is a standard that we need to be followed. So weight loss percentage, color difference, visual defects, shrinkage, pH moisture, TSS, reducing sugar, vitamin C, microbial analysis, these things we were considered. So mangoes stored at 12 degrees centigrade have the extended shelf life of more than 3 weeks. The major observation is only 4.5% of the weight lost at 12 degrees centigrade even after 3 weeks. Larger changes in color was observed for ambient stored mangoes within 1 week, whereas only change in is 10 degree observed from mangoes. So at 12 degrees centigrade, the moisture content reduction in descending order. Water content of 81% preserved in mangoes at 12 degrees centigrade for 3 weeks. Similarly, pH also preserved at 12 degrees centigrade at the range of 4.6 to 4.9. So these are the some food quality analysis, some standards. So for example, the mangoes, if you are maintaining 12 degree, 80 RH is 85, 2 to 3 weeks we can improve the shelf life. So similarly, the 20 degree centigrade, RH is 60, 3 to 4 weeks. Similarly, banana, 13 degree, 90 to 95, 2 to 3 weeks. 2085, 4 to 8 days. Banana yellow, 1385, 3 to 6 days. These are the some standards. Similarly, like a tomato, potato, all kind of articles are there. So only thing is we need to understand how we can maintain what are the relative humidity and all it is required. Sometimes minus is also required. For example, the apple and all -1 to -3. So relative humidity is 90 to 98% is required. So many things like apricots. So that is maintained with a minus 0.5 degree to 0 degree, 90 to 95% of the relative humidity, so that they can improve the shelf life of the cold storage system. So normally when you are considering heat load factors for cold storage, designs are wall, floor, ceiling, heat gains due to the conduction, wall and ceiling heat gains from solar radiation, load due to ingression of air by frequent door openings and during fresh air change, product load from incoming goods, heat of respiration from stored product, heat from workers working in the room, cooler fan load, light load, aging of equipment, miscellaneous loads, if any, many factors we can say that. In fact, if you are referring government, they launch us with different policies and subsidies for the cold storage business. Whether you are a new business owner or investor and looking for the best business from where you can able to get monthly and a long-term income, then cold storage will be always the best idea. If you are referring maybe the Google cold storage units, so many rates, I mean the cost, it will show from the India market like that, many things it is available. Choose the low cost storage for vegetables in India and build the best cold storage now. It requires a one-time investment, and if you will be able to set up a cold storage successfully, then you will get many benefits. So cold storage not only helps to make a profit long term, but it also helps to keep all vegetables, fruits, meat, many things as long as you need. So it will help to increase a further business and improve economic conditions as well. This is for just information. And the studies which we made on the quality parameters of tomato stored in portable storage cold storage room, and the studies on the quality parameters of tomato stored in the portable stored cold storage system. Here the freshly harvested tomato we consider, that is the first stage. Second one is washed and shade dried. The third one is stored in ambient temperature, cold storage with PCM, cold storage without PCM. The samples taken in 3 days interval, analysis for physiochemical properties. Like this only we made it. And these are the tomatoes which we were stored in the cold storage room. And some sensors also we were used for temperature, relative humidity. And this is what the commercially available, this one, this unit. This is only inside this container, the PCM is there. So the PCM, I told you that it will change the state from solid to liquid, liquid to solid. At the same time, it will provide you to maintain the required value of the temperatures and the relative humidity. These are the studies on the quality of the parameters of tomato stored in portable PSCS system. So the physical laws in weight, how much it will be there with respect to the cold storage system, room temperature. So conventional cold storage system. So you can see that the cold storage system, I mean the proposed cold storage system, we are able to maintain, physiological loss of loss in weight of tomato stored in different cold storage conditions we were measured and reported. Then rate of decay, number of fruits decayed with respect to storage days, that also we were reported here. The conventional storage, how many? The cold storage with the PCM, how many? And room temperature, how many? So obviously, when you are using with the PCM and cold storage, definitely the number of fruits decayed, it is going to be reduces. This is for your information. And firmness also we can see that how it will be with respect to the cold storage system with the PCM. And the conclusion is with respect to tomato, the loss in weight is 7.88% in cold storage with the PCM when compared to the other storage conditions. Rate of decaying was more in the cold storage without PCM when compared to the cold storage without PCM. Firmness decreased more in the cold storage without PCM when compared to the other storage conditions. So the studies on the quality parameters of the tomato, cold storage system without PCM, the rate of decaying was more in the cold storage without PCM due to the consideration problems from the power cut off for 12 hours. Post-harvest diseases such as white rot, bacterial spot, soft rot, were more when compared to others through the shelf life is maintained for 28 to 32 days. So cold storage with PCM, the rate of decaying was less in cold storage with PCM due to the temperature maintenance from the latent heat storage by PCM material. Then the shelf life was up to 35 days. So the studies on the performance of the banana stored in the cold, portable storage, cold storage system. So that also we were developed. These are the flow which we were followed. Freshly harvested banana, washed and shade dried, stored in ambient temperature, cold storage with PCM, cold storage without PCM, then samples taken in 3 days interval, analysis for physiochemical parameters. So these are the bananas. In fact, in our area, Trichy area, many banana farmers are there, banana tree farmers are there. So here the requirement is more. banana tree requirements are more. This is the cold storage without PCM, cold storage with PCM, and the physical laws in weight, how it will be with respect to the room temperature, and cold storage with PCM and cold storage that we were reported. Obviously, the physical laws in weight in percentage, it is reduces with respect to the our cold storage system. Right? So similarly, total soluble solids is also less as compared to the room temperature and a conventional storage. So similarly, pulp to peel ratio also we were considered. And the condensation in cold storage of banana is, condensation problems occurs in the cold storage of the banana without PCM due to the power cutoff for 12 hours. You can see that moisture drops were found on the skin of banana, and mold formation on the skin of banana, that also we were observed. These are the bananas in cold storage system with with PCM after 28 days. You can see that. So 28 days it is possible to keep the banana. In fact, Trichy is a very good hub for transportation, banana transportation and onion transportation also. The conclusion is the shelf life of the banana was 8 to 10%, 10 days stored in at ambient temperature. Shelf life of the banana was extended up to 28 to 30 days stored in cold storage, but it depends on the maturity of the banana. After the 20 day of cold storage without PCM, mold occurrence was spotted on the banana due to condensation during the power cutoff. So these are our unit. This unit, the phase changing material waste prototype solar powered cold storage system was developed to investigate the effect of shelf life of the fresh post harvested ripening mango and performance of the PCM based on the portable solar powered cold storage system. So this is the studies performed on the quality parameters of mango stored in portable solar cold storage system. Temperature profile against the time during the experimental period. So I mean with that we were measured, and physiological weight loss is also we were measured with respect to different sample. So physical loss in weight is a physical parameter that is important for satisfying the consumers. Weight is measured by using a calibrator infra digital meter with a 5 kg capacity. Precision balance manufactured by Infra Instruments Private Limited, Chennai. Physical loss in weight measuring the concerning weight at the time of harvesting and storage period, and the difference in weight is accounted for measures the physical loss in weight. Yeah, a rapid increase in the physical loss in weight after 4 days and 50% of loss in weight loss in 14 days for atmospheric storage is observed. In addition, about 7% of physical loss in weight is observed after a week in cold storage mangoes. In addition, only about 4% of losses is observed from day 4 to 11 in cold storage mangoes. Therefore, thereafter, slightly increases during the cold storage period. However, the maximum physical loss in weight measured in the cold storage mango is 17% at 26 day. So these are the primness, total soluble solids, titratable acidity also we were measured, moisture content, so pH value. Similarly, many article we can do it in our cold chamber. And the conclusion is with respect to mango, the work experimentally investigated the performance of the solar powered cold storage system and the shelf life of the ripening mangoes during the storage period in the PCM based system also we were verified. The temperature distribution of and the energy consumption of the PCM based cold storage system shows the better performance, and the grid energy use was very much reduced by 10.34% using PCM. Physical changes in ripening mangoes show quite a variation during cold storage, especially in physical loss in weight, and it is maintained below 18% even after 26th day. Firmness is also agreed to quality, a good quality in cold storage compared with atmospheric storage. Total soluble solids value observed up to 4 days was about 6.1 to 7.7% in both storage conditions. After that, TSS increased rapidly in atmospheric storage, but the trend remains the same as per the researchers' expectation in cold storage. The the pH values were changed vice versa. However, the results exposed that both the parameters are in the range of permissible level. So finally, we were telling that the shelf life of the system it is to be increases. So coming to the chamber, the operating parameters of the following 5 cases are considered. The relative humidity is 80%. Chamber temperature is 5 degrees centigrade. So the solar powered cold storage system without PCM, without solar energy and PCM, only it is operated with the grid power. How it will be the performance? So the cold storage system without solar energy and PCM, when the grid failure is there and power failure, grid power and power failure is there, how it will be working? The system with solar energy, no grid power, and system with the PCM, grid power and power failure is also we were considered. And system with the solar energy and the PCM, absence of grid and the PV power. So this is the system without solar energy and PCM, only we were maintained with the grid power. And here you can see that here we are maintained with the temperature. The temperature variation is 4 to 6 degrees centigrade, and RH is 80%. We are able to maintain 78 to 82%. It is varying. This is for 1 hour cold room temperature we were observed. This is the atmospheric temperature. The system takes 9 minutes to attain the set temperature from ambient temperature. Temperature and RH maintains within the set limits for entire day. And grid energy is supplied a full day without any interruption. And the second case study is we were maintained the same thing in this instant. You can see that the compressor power is cut off. So when the compressor is cut off, in the sense, immediately the cold room temperature is also reaching to the room temperature. So it is reaching to the room temperature. This is the observation. The system are the same thing, first point. Second point is switched off after the 12 hours. This is the recorded data. In a particular day, we were recorded all these information. Switched off after 12 hours. The time duration to attain different temperature as follows: 4 to 5 degrees centigrade 12 minutes, 6 to 10 degrees centigrade 32 minutes, 11 to 15 degrees centigrade 53 minutes. So here you can see that the system it is operated with only solar power. Only solar power. So this is what the instant at which the absence of solar energy. Because we know very well the solar power it is going to change time to time. Morning 6 o'clock, one solar energy, 7 o'clock, 8 o'clock, 9 o'clock, 12 o'clock, the solar energy is peak temperature, we may get it. So the inadequate solar energy after 5:15 p.m. lead to power off to system compressor. It is this time durations to attain different temperature as follows. 4 to 5 degrees centigrade for 30 minutes, 6 to 10 degrees centigrade for 31 minutes, 11 to 15 degrees centigrade for 49 minutes. And the system with the PCM. So I told you the property of the PCM. We were introduced. PCM maintains the set temperature with absence of grid and solar. That also it is possible. So the same thing, the PCM maintains the temperature near constant for 83 minutes for 25 kgs of mass. This is what we observe. The time durations to attain the different temperatures are as follows. 4 to 5 degrees centigrade for 83 minutes, so for 6 to 10 degrees centigrade for 69 minutes, 11 to 15 degrees centigrade for 135 minutes. So system with the solar energy, and this is indicates with inadequate solar energy after 5:05 p.m. lead to power off to the system compressor. So here you see that PCM maintains the set temperature. Maintains the temperature near constant for 82 minutes for 25 kgs of mass. The time durations to attain different temperature as follows. 4 to 5 degrees centigrade for 82 minutes, 6 to 10 degrees centigrade for 66 minutes, 11 to 50 degrees centigrade for 137 minutes. So comparison with respect to second case study and fourth case study. The blue color indicates with the system runs with the grid power, considering the power cut and without PCM. The PCM maintains the temperature to below the atmospheric temperature for entire day. The red color indicates with system runs with the grid power, considering the power cut and the PCM. The PCM maintains the temperature to near constant value for a period of 83 minutes. The cold room temperature for case 2 and case 4 were reported here. And the PCM maintains the temperature to near constant value for 83 minutes. The temperature 5 to 10 degrees centigrade for a period of 83 minutes. So this is the case study for 3 and 5. The PCM maintains the temperature near constant value for a period of 83 minutes. Temperature 5 to 10 degrees centigrade for a period of 66 minutes. Irradiation, wind speed and cloud formation tends to alter the solar energy during course of time period. Differences in temperature in 2 different days. Cold temperature in degrees that it is indicated with case 3 and case 5. So the here the PCM maintains the temperature near to constant value for a period of 83 minutes for 25 kgs of mass. Temperature is 5 to 10 degrees centigrade for a period of 66 minutes. Irradiation, wind speed and cloud formation tends to alter the solar energy during the course of time period. Difference in temperature in 2 different days. So the chamber temperature with 1 degree centigrade also we were observed. These are the various cases which we considered. System without solar energy and PCM grid power alone it is operated. System without solar energy and PCM, grid power and power failure. Grid power and power failure with PCM with PCM. So system with solar energy and PCM, absence of grid and PV power. Here you can see that the same system. This case study was conducted for a duration of 24 hours. The system takes 6 minutes to attain the set temperature from the ambient temperature. The temperature and RH maintains within the set limit for the entire day and the grid energy is supplied full day without any interruption. So this is the second, in this case study, you can see that for first 1 hour temperature, how it will be varying. The system compressor is switched off after 12 hours. The time duration to attain the different temperature you can follows. And when the system compressor is switched off after 12 hours, the chamber maintains the temperature of 13 to 15 degrees centigrade in 10 minutes and 20 degrees centigrade for 105 minutes. Due to the lack of charged PCM, the system is not able to maintain the set temperature for a longer duration. So this is the third case study. System runs with the phase changing material alone. You can see that the set temperature can maintain for 205 minutes instead of 12 minutes, and simultaneously 460 minutes the system can maintain the temperature for 16 to 20 degrees centigrade instead of 105 minutes. So here you can see that the runs with the grid power, runs with the solar PV power, runs with the PCM material. So everything we captured, and it was understood that the solar powered cold storage system room chamber is maintained temperature of 14 to 16 degrees centigrade, relative humidity of 80% for the set point, with slight deviation from the set point under no solar power. So these are the tomato results with respect to different scenario. And so our contribution is, if you are using such a solar based hybrid cold storage system can meet the supply and demand of food, people get fresh and healthy fruits and vegetables around the entire country, quality of food commodities get enriched. So beneficiaries, farmers, providing information about the food commodities wastage, revenue loss for food wastage, transport and storage facilities of different commodities, vendors providing information about energy utilization and the difficulties of long-term storage of different products in various environmental conditions, cost-effective hybrid cold storage system with the different environmental conditions. So the indicators, efficient indicators, we were considered that with respect to solar energy is in conventional mobile storage system, the diesel engine is used to provide the cold storage, but we were used with the solar and phase changing material. In PV based mobile cold storage system, battery is used for as a energy storage device. So shelf life commodities are post harvest losses can be reduced by storing the fruits and vegetables at a harvest place itself. The benefits are energy demand reduction, energy demand reduced by 15.34% using the PCM and solar PV power, environmental and economic impact, eco-friendly, cost-effective system when compared to the battery energy storage system. Social impact is using such a solar-based cold storage system can meet supply and demand of food. People get fresh and healthy fruits and vegetables around the entire country. So in fact, we conducted some workshops based on this project. This is that invitation and our workshop brochure. So in this workshop, we called the chief guest are Ajithan, Managing Director, Tamil Nadu Banana Producer Company Limited, Tiruchirappalli, and Karigalan we called Managing Director, Nachalur Farmers Producer Company Limited. So based on them only we were inaugurated this one. And these are the workshop details. So when we were demonstrating the unit. In fact, Madam was our Dr. Mini Saji Thomas, former director of our institute. She was inaugurated the unit, and some paper cuts we were getting through. I mean, we were published through newspapers. So some local language also, in Tamil language also we were published. So some photographs we were, he is Professor Jayabharata Reddy, Professor Mariappan, Dr. Babu, Jayabharata Reddy, we all are involved. So in fact, we kept it the system in the conference stall also. Some feedbacks we got it, and these are the during inauguration we were taken with some photographs, and these are the paper cuts. So I just want to tell you here, he is the former director of Indian Institute of Foodcraft Technology, and he is the director of Banana Research Institute. So he is the DGM of BHEL Tiruchirappalli, Dr. Dharmalingam. And so these are some paper cuts. So some demand is always there, and a techno-economic study also we were made with respect to our system, and these are that. So finally we were concluded that this is the revenue from electricity saving, revenue through cold storage per year is this much. This we have proved, this is what outcome of our project. And revenue from the electricity saving is a 9 kilowatt hour per day. And revenue through energy saving per year with respect to our system is 17.11 percentage. So many things we can do it. These are some informations, and under the increasing the insulation in the existing cold rooms, that also the improved model, and these are some publications related to our publications, our own publications, which we got it from this project. And under this project, 3 PhD scholar from NIT Trichy and 1 PhD scholar from IAFET were awarded, 2 MLs, PG students. So thank you. Any discussion, you please.
Sir, good afternoon, sir.
Yes, good afternoon.
Sir, all are joined in YouTube link, sir. They are shared in queries in YouTube link channel only, sir.
Okay.
They are not. There is no queries from any participants, sir.
Okay, sir. Okay, sir.
Okay, sir.
Okay, sir. So I am ready to answer for any kind of queries related to this. In fact, many benefits are there with respect to the commercial cold storage systems for storing the fruits, vegetables, like that. In fact, I have given many introductions related to the cold storage. With respect to this, is one of the applications which we were chosen from the solar PV system. In this project, mechanical engineer is also involved, electrical engineer is also involved, instrumentation engineer, food engineer, all we involved and developed a unit. And this unit is very much essential for the society also. So thank you everyone for your cooperation and listening. Any queries, even I am ready to answer through email also.
Okay, sir. Okay, sir. Thank you, sir.
So I am closing this session now.
Sir, I am Sujata, sir.
Yes, ma'am. Please, ma'am.
Sir, thank you so much, sir. Presentation is excellent, sir.
Thank you, ma'am. This is the DST project which we got it, ma'am. So right now we completed this project, and whatever the experimental work which we carried out at NIT Trichy, that only we demonstrated here. Ma'am.
So, okay, sir. If we need anything, we'll approach you, sir.
Sure, ma'am. Sure.
Thank you so much, sir. Thank you, sir.
Thank you, ma'am. Thank you. Thank you so much, ma'am. Thank you.
Sir, this is Surya, sir. Good afternoon.
Good afternoon, ma'am. Good afternoon.
Thank you for your elaborative explanation.
Yes, ma'am. In fact, I touched the electrical part, mechanical part, food side, many
Yes.
many aspects I have touched. But
Yes.
it is very difficult to understand within 1.5 hour, 2 hours.
Yeah.
But one is interested, we are ready to demonstrate.
Sure, sir. Sure, sir.
Okay, madam. Okay.
Thank you so much.
Still, many students are pursuing projects, PhDs under this area in our institute.
Yes. Okay.
Okay.
Sure, sir.
Thank you, ma'am.
Thank you so much.
Thank you, sir. Madam, with all your permission, I close this session, madam. Before going to vote of thanks, I have given to you.
Sure, sir.
Yes, ma'am.
Okay. On behalf of Triply Department, today I take this opportunity to put all my gratitude in the form of words. First of all, I would like to thank our today's eminent speaker, Dr. S Senthil Kumar, Sir Garu, for accepting our request and for giving such a wonderful presentation on emerging trends and challenges in renewable energy systems and making event meaningful and interesting. Thank you very much, sir.
Thank you, sir.
I would like to thank our chief guest, Professor P. Sujata Madam Garu, for accepting our request to be a chief guest for this FDP and sparing her precious time in this event. Thank you, Madam. I would like to express our proud gratitude to our principal, Madam Dr. Syed Surya Madam Garu, for her constant support and encouragement throughout the program. Thank you, Madam. I would like to extend my heartfelt thanks to our beloved correspondent Madam Srimati V.K. Padmavathamma Madam Garu for her encouragement. Thank you, Madam. I would like to thank our director, Madam Srimati V.K. Srivani Madam Garu, who has initiated us to do this program and their continuous support right from its inspection. Thank you, Madam. I would like to express my gratitude to our Managing Director, Sri G. Raghunath Reddy sir. Thank you, sir. Thank you so much, sir, for and supporting us, guiding us in right way. My heartfelt thanks to our whole entire team, Triply Department, that is Ramakrishna sir, Paramesh sir, P. Mallesh Reddy sir, Reshma Madam, Vasu sir, Rambabu sir, and Chinnasunkai sir for their continuous support in making first day of this FDP successful. I big thank you Noor Muhammad, sir, Mechanical Department, who is the backbone of this online section by providing technical support. Thank you, sir. Finally, at the end of this section, I would like to thank all the participants of this FDP for their religious presence. Thank you, everyone. Thank you, one and all. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Madam, can I leave, ma'am?
Yes, sir. Thank you, sir. Thank you very
Thank
much.
you, ma'am. Thank you, ma'am. Thank you, Sujata, ma'am. Thank you, ma'am.
Sujata madam, thank you, madam.
Thank you, ma'am.
Thank you, ma. Thank you, ma.
Thank you, madam. Thank you.
Thank you.